Lucas, this is our Skype tutorial online, Rob's TV, part of the program package you're doing in the 9-month Pilot Pro course. And what we're doing today, Lucas, is I'm going to explain to you a little bit about weather, high pressure and how it works. The mouse you can see moving on the screen, and the red arrow and the little A sign, that's the Malverns. The Malverns is 1600 feet top to bottom, and it takes mainly an east wind direction. Generally we go there to do cross country in the month of April and May, or general thermic flying. Nice big ridge, easy to push out and catch thermals. So what I'm going to do is bring up a high pressure. Lo and behold, there one appears. They always track from here in the southwest of England. They rotate and they move up and out to the northeast. So we'll pick today as a Saturday, and the high pressure is rotating like that. We'll call that Friday actually. And then what happens is we will move into Saturday, and you see where the A is, can't you? Just there, Lucas?
Yes, I can see it.
You can see, good man. So what happens is I'm going to ask you a question now as I rotate this. I want to know the wind direction on Saturday, let's say next April, this would be 24th or something like that. What is the wind direction at the Malverns, please?
I would say it's north.
Good man. So we've got a high pressure. There's the center of the high. This would be like 1024 here. Now I'm going to move on up to about there. That'll be about Sunday. And we're going around. What direction at the Malverns do you think we would have?
I think it's northeast.
Good man. So for anybody watching, the wind's coming down like that, and it's got more of a northeast aspect. So that was Sunday, I believe. And then if we moved over to about there being Monday, what wind direction do you think we'd probably have at the Malverns there?
It's obviously east.
East wind direction. So we've got a good wind direction because the Malvern there takes the east, and the high pressure's rotating around. And we probably would have cold air, hot sun, and also the Malvern obviously faces east, and the sun comes up in the east, so the air, the sun would strike the front of the Malvern slope because it faces east. The sun rises in the morning, it's cold in the morning, high pressure usually the night before, as we've just had 3 days of high pressure coming through. There's probably no cloud at night time. That means when the sun strikes the surface is going to be cold, maybe frosty, and then it gets very hot, very quick, and the temperature change brings thermal activities. With the wind direction, as you quite rightly say, being an east, it means that the site is suitable, quite likely, for a fairly good flight. But here's a little question for you. If the pressure was 1030 here, do you think the air would rise very quickly?
No, I don't think so.
Why would that be?
No, let me think. When we've got the... No, it shouldn't be, because the high pressure, the air is going down.
Okay, so in a pressure system which is very high, the air will flow down, won't it? So you've got the scenario where here we don't know obviously how high the pressure is, but when that pressure gets to about 1030, the air mass is quite sinky. So it may well be thermic, but the thermal will sort of go up and start to come down pretty sharpish. So as you just said, it's not going to be so suitable at 1030. But what happens here is you're able to understand the wind direction and which day to come in flying to go there, wouldn't you? You can understand that.
Yes, definitely.
Yeah. All right. So let's just take that to say sort of like Tuesday. Let's call that Tuesday. Still at the Malverns. What wind direction do you think we would have now?
Would be probably northeast.
No.
Okay, so I would say rather east.
Yeah, it may have a slight southeast, sorry, but it's probably still east. And if it's on the outside of the high pressure there, the pressure might be very high. Let's just say 1030. You could take off there, and the pressure's so high, you just sink all the way to the bottom. You wouldn't go up. You know, you don't know because we haven't put those pressures on. But that's very useful for you to start to understand that pressure at the end of the day. Wind direction is good to understand and forecast that. The understanding of pressure is so underestimated when you learn to fly. If you take a wind meter out, for instance, and stand on top of the hill and the wind meter says 10 miles an hour, it won't tell you the pressure. So the pressure, say between 1000 and 1024, is really quite useful for flying. When you hit 1030, you tend to sink like a stone, and if you go below 1000, you tend to enter low pressure, and the air can be quite lifty. But you may just continuously go up, let's say to a certain degree. So we tend to teach and fly in pressure between 1000 and 1024. Does that make sense?
Yes, it does.
Brilliant. Okay, that was just a little example of what we do here at Rob's TV, which I'm going to show. You can look at this later, obviously, Lucas, in your own time to go through that to memorise this. How much wind do you think there will be at takeoff? I know you haven't been to the site, but you see the distance of the isobars apart in this high pressure. What wind speed would you guess or presume would be at takeoff at 9 o'clock, let's say?
Okay, I will answer you this question, but if you tell me something before, does it mean if you've got the center of the pressure, the wind increase while it's going to the edge, to the end of the pressure?
Aha, very good question actually. Is the high pressure is sinking air, remember? And as it goes around, it's like a helter-skelter. So in the middle, you start off a bit slower, and as you go to the edge, it gets quicker and quicker as you go down the helter-skelter. So the airflow is pushed out, because the airflow, if I simulate this in the camera actually, the airflow as it goes around in the high pressure here, which you can't quite see, I don't think. No, you won't be able to see this because we're sharing screen on Skype. But as it goes clockwise, it sinks. And it's pushed out here. That's mainly for the viewers, but you can watch this later, Lucas. So the high pressure is going around clockwise, and it's pushed down and sinks out. So I would say yes, at the edge, it's probably going to be windier than the centre. By how much will depend on how many isobars generally, but on the outside it's definitely going to be windier in my opinion.
I think nowadays I can understand weather much better.